everyone, myself Harjogunpreet Singh Sidhu, and today I am here to demonstrate my assignment number 1 of image processing and analysis, in which we are inputting the images and playing with the images, like shifting the channels and like inverting the images, replacement of the pixel. We will understand uh, about the images, how we have to process the image in the Python. So here is my code for the for everything. I will explain you the code, but let me run it first. So let me run this code, and a1 underscore script on py. Yeah, so this is the basic images. I'm inputting the image and showing it to the user, two images, and this one I'm swiping out the blue and red color. I'm swapping the blue and red channel of this image, and for this image I'm just showing the green channel of the image. This one only the red channel, I'm just showing the red channel of the image. This one I'm converting the RGB to gray color space. This one, if you will see in the middle of the picture, there is the image of the different picture. I have adjusted to the in the middle of the Mandari image. This is normalized image. I will explain you how I did it. And this one is shifted. If you will see on the right hand side, like 2 pixel is shifted from left to right. This one is subtracted image. Just we subtracted normalized image from the original image. This one is flipped image. We flipped the image. And inverted image means we given dark high intensity colors the lower intensity, and lower intensity the higher intensity. Will explain you. This is the Gaussian noise image, in which I put the Gaussian noise and then merge the image. Okay, now I will explain you. So for better demonstrating purpose, I have created the Jupyter notebook. So I am using the NumPy so that I can have my data in the NumPy, and matplotlib so that I can show the images, how the images look like. And I am read a library from skimage.io to take the input from of the image, and RGB to gray to converting from RGB color map to the gray color map. So in this code I am just reading the image. I am putting the image, taking the image and putting into my two variables, image and image underscore 2. And here in this part I'm just displaying, making the plot of the image where I can show the images. So it's the output of this code. So by running this code I got this output. So here I'm swapping red and blue channel. So what I am doing here, in this one is for width, this one is for height, and the third parameter is for color channel, in which we have different channels. 0 means red, 1 means green, 2 means blue. So here I am putting 2 because I want blue intensity in place of red, and here I'm putting 0 because I want red color intensity in place of blue. So I'm just swapping these number. So if 0 is here, 0 means this place is of red, but 2 means blue. So we are putting blue instead, blue in red, and here we are putting red in blue. So after swapping, how the image look like is the output of that image. And in this part of the code, I'm just showing the green channel image. So what I'm doing, I'm leaving, like I'm taking all the number of rows and columns and here I'm just showing channel number 1, that is green channel. 0 is red channel, 1 is green channel, 2 is blue channel. So I'm just showing green channel here. So here's the output, and I label it as img underscore g. In this part of the code I'm just showing the red channel. So as I already told you, 0 means red, 1 means green, 2 means blue. Here I'm just putting 0 because I just want to show the red color image. So it will only take the red intensity, red channel intensity, and will only show that here. In this part of the code I am converting my image from red color RGB color map to the gray color map. So I'm using the built-in function RGB to gray, and I am giving the input as a parameter to this function, and I'm storing in img underscore gray. So I'm just outputting my image here. So this is the output of how the image will look like. So now comes the interesting part. So in this part of the code we are taking the 100 by 100 by 100 pixel of the one image from the center and putting into the other image in the same place. So in the first line I am just taking the I'm finding the center of the image 1, that is image from this image. I am just taking the center of that image. So this will give me the row, this will give me the column. So x coordinate, and this one will give me the y coordinate. So but I want 100 by 100 by 100 from the center. So what I am taking it, I am taking from this image. My first input is, as you know, is the row. So we are taking center minus 50, 50 from left side and 50 from right hand side. So we are taking 100 pixel, 100 pixel row, and the second part is the column. So we are taking the 50 pixel from up to 50 pixel down. So it gives me 100 by 100 pixel from the center, and then I converting the image to, that is Mandheri image, to RGB2 because I want them in same color map. So I'm copying that make a copy of that image and store it in image modify, and then I will take the image modify both the center coordinates 100 by 100. That is the same one that we did it over here, and we will give this one, match this one to this variable, so that the 100 by 100 pixel from the center will be shown as the other picture that we have stored in square variable. So here is what I'm getting the output, pixel replaced image. So we have the 100 by 100 image in the center. So here I'm printing the mean, standard deviation, minimum, and maximum. We are using NumPy library to find it, and here I'm getting the here I'm getting the output, what is the minimum, maximum, mean, and standard deviation. So that gave me that thing. And here I'm using normalized image. For normalized image, what we have to do it, we have to subtract mean from the image and divide it by standard deviation, that will give us normal, and then we are scaling by the factor of 10, and then we are adding back again the mean. So that will give me the normalized image. Here is how it looks like, this image. I am doing this one on the img underscore g, that is the image with only the green channel, because that's given in the question. So here I'm doing shifting of the image. So if you will see 2 pixel is shifted to the right hand side, instead of it's cutted from the left hand side and it's put it in the right hand side. So what I'm doing, I'm using the numpy rule, that is it's changing the pixel, so it's shifting the pixel. of this image by -2, so it's shifting to the left hand side on axis 1. Axis 1 is row, sorry, column. So it's shifting from the column, like every row is shifted by 2 pixels to the left hand side. That's what it means. It's shifting the rows, but that shifting of rows give us the illusion of as we are shifting the columns. So this one we are just subtracting the original image from and we are subtracting the shifted image from the original image. So that's why, because this image is shifted -2 pixels, so that's why we have the sharp edges here, we are able to see it. So to subtract it, we are converting into float type, because our answer, when we are doing subtraction, our answer can be in float. So that's why we are making it float and then doing it, and we are showcasing that. And uh, if I'm not doing here the color map gray, let's see which output I'm getting. Give me a second. Yeah, so this is the output I'm getting. Little bit green here. Sorry, I forget to do it before. This one is flipped image. I'm flipping the image. uh, I don't know why. Give me a second. Why my colors are filled? Let me rerun it. Okay, I think I will explain this later. So in flipping of the image, I'm just flipping the left to right. So I'm using the img underscore g that is given in the question. So I'm just flipping it using the property from numpy, and I'm just flipping it. If you will see, our image is flipped. And in inverting the image, so we are inverting the image. So I'm just subtracting all the pixels from 255, so that if it's already on high intensity like 255, that will give me zero intensity. After subtracting from 255, the lowest frequency will have a high frequency. For example, if the image pixel has zero intensity, then it will have 255 intensity. And this way the light becomes dark, becomes light. And here in the noise, when I'm generating the noise, I'm using the numpy random method. And this one means that I'm doing for every pixel, I'm subtracting it to 25, and then I am adding it to the our image. If I'm doing anything different, for example, let's do 250. See this one, this time it's a blur. Now see, I got all my images back into original colors. So but here I'm using 25, just a random thing, so that it will look clear. I'm using the Gaussian noise. I'm using 25 as a standard deviation. So this is all my lab. And this is that the Jupyter notebook is just for explaining purposes, but this is the Python script that you can learn to get the images, like displaying both the images. I have put at the comments as well, so that it's easy to know which code is for which part. Swapping blue and red color, monochrome image by selecting only green channel, image by selecting only red channel, image to grayscale. Now this one is scale of 100 by 100 pixel located in the center. What is minimum maximum pixel value of green? A normalized image, shifted image, subtracted image, flipped image, inverted image. And this one is take the original image that was given in the instruction. I'm using standard deviation of 25. And that's all my lab. I hope it's I explained well. Thank you.